Welcome to the next video in the Gen Chem Fundamentals series presented by MCAT Genie. So this video is going to be about unit prefixes, and these are going to be attached to SI units typically or derived units on the MCAT, and we're going to need to be able to convert between them from time to time. So I've separated the two sides of this with the dashed line to represent how these numbers above this dashed line are going to be larger than 1. So 1,000, 1,000,000, 1,000,000,000, and 1,000,000,000 respectively, from kilo, mega, giga to tera. And then on the opposite end, the numbers centi, milli, micro, nano, and pico are going to be 10 to the negative 2, which is 1/100th, as you would know from centimeters, for example, or millimeters, which is 1/1000th, or 1/1,000,000th, like micro, and nano will be 1/1000,000th, and pico will be 1/1000,000th. So a lot of these are separated by 10 to the 3 or 10 to the negative 3, which would be multiplying by 1,000 or dividing by 1,000, besides centi, but hopefully you get the point. You guys are probably familiar with this already. So let's move to some examples. So let's start with a very basic example of something you might have to do. So let's imagine you have 10 millimeters and we want to change that to meters. If that is the case, then what are we going to do? It's going to be as simple as taking into account the fact that milli means 10 to the negative 3. And so how many meters is this going to give us? If I was to put this in a proper scientific notation, well, 10 times 10 to the negative 3 is going to be the same thing as 1 times 10 to the negative 2 because I multiplied it by 10. If I was to write this as a decimal, then this would give us 0.01. If I was to go 2 spaces to the left, then that is what that would be equal to as a decimal. So it's as simple as writing the prefix and what it stands for, 10 to the negative 3, in front of the SI unit in this case, which is our base unit of meters. So this makes our life pretty easy whenever we need to do that. And I wouldn't even bother too much with changing things to proper scientific notation when you're on the test, because you could probably just use it in an improper looking form, but it'll mean the same thing. So we'll see examples of that later if we need to. And if we were to convert between meters, let's say 10 meters to millimeters, I always recommend that we keep in account or take into account the physical situation. So just like in the last case, I would expect that if I had 10 millimeters, then I'm going to have a much smaller amount of meters because meter is a larger unit. But in this case, if I have 10 meters, then the quantity or the number that's going to present itself here in terms of millimeters likely will have to be much larger. So if you keep that in mind, that will help you remember whether you need to multiply or divide or what it is that you need to take into account. So if milli is 10 to the negative 3 for meters, well, if I want to change meters to millimeters, then I have to do the inverse of that. So this is going to be 10 to the 3 times as many millimeters. And if we were to write this out, it's simply because 1 meter is 1,000 millimeters. So if I'm converting between millimeters to meters, then I'm essentially going to be dividing by 1,000. But if we're going to flip this relationship, then I also know that 1,000 millimeters is equal to 1 meter. And therefore, if I want the meters to cancel out, then I will need to multiply by 1,000, which is essentially what this represents. So if you want to write it out as a fraction and see the units and do the typical dimensional analysis, feel free. I will never stop you from doing that. However, I tend to think about it more logically rather than writing out the actual conversion. So something you'll get used to. And in this case, this is going to represent the number of millimeters that we will have. If I'm to convert this to proper scientific notation, then this is essentially going to be 1 times 10 to the 4 millimeters, which is the same thing as 10,000 millimeters, which makes perfect sense because there's 1,000 millimeters in 1 meter. We started off with 10 meters. We end up with 10,000 millimeters. It just makes sense. You add 3 zeros. Okay, so this was a very simple explanation for the one-dimensional unit conversions. But what happens when you run into a situation where you're given a unit such as centimeters. It's going to be the same area technically, but it's a unit conversion for the area. And so if I say here's 1 centimeter squared, and I ask you how many meters squared is this going to be, then a lot of students unknowingly are going to say, well, it's 1 times 10 to the negative 2. Didn't you say that? And the answer is yes, it is going to be that. However, we do have to do one more thing, which is put that to the power of 2 when you are determining the difference between centimeters squared and meters squared. And so if I'm going to break that down really quick for you, then you have to take into account that we have a square, essentially, or a rectangle, or something that we have the area of, and it's two-dimensional. And if I say, here's 1 centimeter, let's call that the length, and then here's another centimeter, and that's the width, then that will equal 1 centimeter squared when we multiply them together. But if I am to ask you, okay, how many meters squared is that? Well, then let's change our centimeters to meters in each of these scenarios. And so if we do that, well, then this 1 centimeter is going to be 10 to the negative 2 meters. And this other side is also going to turn into 10 to the negative 2 meters. So if this is the case, then that means we're going to multiply 10 to the negative 2 times 10 to the negative 2, since it's two-dimensional, since we're finding an area. So that is what this squared is accounting for. It's just saying 10 to the negative 2 times 10 to the negative 2. However many dimensions we're dealing with, that is the number of times we have to multiply the unit conversion, and therefore we use the exponent of 2. So I hope that this was a decent example of how you would convert this. So what is our answer actually going to come out to? It's going to come out to 1 times 10 to the negative 4 meters squared. Okay. Now let's move on to the next example, and I'll change the unit conversion to something else just to make this a little bit more difficult and a little bit more interesting. So let's say I was to change from 1 micrometer cubed to meters cubed. So instead of dealing with just length and width, and I hope you guys appreciate my artistic skills a little bit here, I'll try my best. Let's assume we're dealing with a cube because this is a three-dimensional figure now. And so if each side is 1 micrometer, and then we'll say that the height is 1 micrometer. Well, now in this case, what do I have to do with micro? So since I know that micro is 10 to the negative 6, well, then if we're following the same relationship as before, you may have guessed it, we need to cube this because this conversion is going to apply to all three of these sides. And so easily enough, that's going to be 10 to the negative 6 to the third power. So that, if you remember exponent rules, is going to be negative 6 times 3 because it's an exponent to an exponent. So ultimately, we are going to get 1 times 10 to the negative 18 meters cubed. So just to make this very clear as to how large of a difference this is, 1 times 10 to the negative 12 was 1 trillion times different. 1 times 10 to the negative 18 is a million times a trillion, or at least 1 trillionth times 1 millionth. So very small in comparison to the meters cubed. However, it is the same quantity. So 1 micrometer cubed is equal to 1 times 10 to the negative 18 meters cubed. If you needed to go vice versa, then you would have to do the opposite of what I said. And this is where it becomes really important to keep in mind what you're dealing with. So, for example, if I was to, for some reason, take my volume of 1 meter cubed and need to change that to, let's say, nanometers cubed, then we're just going to follow the same pattern, except you have to take into account that a meter cubed is much larger than a nanometer cubed. So the number of nanometers cubed that I would need, the number that's going to be in front of this, has to be a large number. It just has to be. So if I was to divide here by anything, that just wouldn't really make sense. I'm not going to use a negative exponent here. So what I'm going to do is I'm going to say, okay, well, meters and nanometers are a billion times different. And I know I'm going to have a billion nanometers per meter. And so there's three sides to that. So I'm just going to say a billion, and then I'm going to cube it. And what's that going to give me? So essentially, that's going to lead me to 1 times 10 to the 27 nanometers cubed, which is a very large number if you were to physically try to think about this. I hope these basic examples were helpful and showing you some different variations of going between unit conversions. So then we'll apply this to the larger context of the test at some point. This was just part of the Gen Chem Fundamentals series, so keep that in mind. And I hope I see y'all again soon. Thank you for watching.